We've talked about substitution and elimination reactions as competing reactions, and our idea in general has been that it tends to be either one or the other. So we've talked about, for example, that we get elimination tends to dominate, strong bases favor elimination, whereas substitution tends to be favored when we have a weak base. And we want to spend a little bit of time talking about reactions where we can actually get a mixture of products from both types of reactions. And this tends to happen when we have weakly basic nucleophiles and fairly highly substituted leaving groups. So it's most prevalent with tertiary leaving groups and weak bases, but it can happen sometimes with secondary leaving groups under protic conditions as well. So here's one example where we're challenged to predict the three different products, including a pair of constitutional isomers and an unrelated compound, for the reaction below. And remember, we're thinking about both substitution and elimination, so we want to try to predict the products of both of those reactions. Let's take a few minutes and see what we can do. And let's think first about substitution. That's probably maybe the easier one to think about because we simply are replacing our leaving group with our nucleophile. Our starting material is achiral, so we don't have to worry about stereochemistry. And of course, since it's tertiary, this is going to be an Sn1 reaction. Cyanide, in addition to being a nucleophile, of course, can be weakly basic. So when we want to think about the elimination reactions, we want to consider also not just where our leaving group is, which is going to leave for both substitution and elimination reactions, and of course that's on this carbon here. We want to think about nearby hydrogens. And note that in the ring, of course, we have two carbons on either side that have hydrogens. And we've also got another carbon here that has three hydrogens. Now, we're tempted to think, well, that would give us three elimination products. Double bond here, double bond here, as well as exocyclic double bond. And what we want to recognize is that we don't see three different molecules here. What we're really looking at is two different molecules, one of which is drawn twice, right? Because this one and that one, those are the same compounds. So the two constitutional isomers are our elimination products, and the unrelated compound would be our substitution product.